Okay, so basics of geometry. How would I figure out how far it is from A to B? What's one way of doing it? What's one very basic way of finding how far it is from A to B? Braden. Counting the numbers. So I just count on over. 1, 2, 3, 4, 5, 6, 7, 8. The distance from A to B equals 8. Okay? Besides counting, because counting might be really tedious if it's like 46 away from each other, what's another method we can use? Yes, sir.
Add A and B together. Whatever those numbers are,
Add them together. So negative 3 plus 5 equals 2. Is that the distance in between them? Not quite. You're on the right ballpark. You're in the right ballpark, Donovan, but we don't add them. How about we subtract them? Okay. What's 3? What's 3? Negative 3 minus 5? It's not 8. It's negative 8. There's an issue here. Evie, how far is it from Madison to Sioux Falls? About minutes, but how about miles? How about 45 miles? Because if you drive 60 miles an hour, you go about a mile a minute. About 45 miles, right? Somewhere in there. Okay. All right. Lucy, how far is it from Sioux Falls to Madison? About 45 miles, right? Yeah. Do you ever see a road sign that says negative 45 miles? Or negative this or negative that? Can distance ever be negative? No. So, what math feature can we use to make everything positive all the time? What have we used in math before to make numbers positive no matter what? Yes, Devin. There's little bars that make it happen, right? Jenny. Not reciprocal. What are these? Absolute values. Yeah, if you use absolute values around your subtraction, that'll make it positive, and then this will be the right distance. Okay, finding distance. Another way of finding distance is, how far is negative 3 from 0? 3. How far is 5 from 0? 5. If you add those two together, that's the adding one, you get 8. Okay? Figure out how far a number is from 0. And if they're on opposite sides of 0, you just add those two values together. Okay? So there's different ways of finding things. So not in geometry, you don't always have to use the same method, but there's a right answer. Okay. Now, we will have a lot of vocabulary. I handed out a vocabulary sheet today. Okay? You will write vocabulary words down on your vocabulary sheet. And then we will use those to study for a vocabulary quiz or two. And then at the end of the chapter, on the day of the test, you'll hand that vocabulary sheet back in, all filled out to me for extra credit on your test. So this is your extra credit opportunity. So your first vocabulary word is an undefined term. We'll describe it as a point is a location and has no size. It's the fourth word down on your sheet. The fourth word down on your sheet is point. Okay? A point is a location and has no size. So, We use a symbol as a dot to represent a point, and we use a capital letter to note it as a point. Okay? So that's a point. A line has a little bit longer definition. A line is an infinite number of points on a straight path that extends in two opposite directions with no end and no thickness. So a line goes on forever in each direction. A line goes on forever in each direction. That's why a line has arrows at the end of it when you draw it, because it means it goes on forever. Okay, I'll let you write that down.
Do we have to write it exactly or just?
I want it very close to that because that's how it's going to look on your vocab quiz.
I was just thinking as we understand it.
No, I want it written probably the same way, because that way it'll be written very close to that on your vocab quiz, so you need to know what it says. So line goes on forever in both directions. Okay? Usually we use two letters to name it, 2 points in it. Or if there's not any points that are signified on it, we can use a lowercase letter to represent it. But most of the time we use 2 letters and the line symbol, which is arrows at both directions. A plane is a flat surface that goes on forever in 2 directions. So a plane is like the floor, the ceiling, the wall, but it goes on forever in each direction. So that's a plane. Okay, those are our 3 undefined terms that we basically described, but they're our starting point of geometry. You got to start with a point, a line, and a plane, so then we can use those to describe other geometry items, such as a segment. A segment is part of a line. Okay? A segment is part of a line that has 2 endpoints. It doesn't go on forever. Okay? A segment is part of a line because it doesn't go on forever. And most of the time in geometry, we'll be using segments more than lines. So a segment is part of a line that consists of 2 points called endpoints and all the points in between them. And we use the 2 endpoints and the segment symbol to name them. Okay, so that's a segment. So a segment has two endpoints. A ray has one endpoint. A ray is part of a line that consists of one endpoint and all the points to one side of that endpoint. So M is the endpoint. It goes through N and it keeps going forever. And we symbolize it by using the point it starts at, and then the other point it goes through with a ray symbol above it. Opposite rays are rays with the same endpoint. They lie on the same line. So opposite rays create a line. Opposite rays create a line. They have the same endpoint. One goes this way, one goes that way. So opposite rays basically make a line. One goes one direction, one goes another direction. And last but not least, an angle is formed by two rays with the same endpoint. Each ray is the side of the angle, and where the two endpoints meet is called the vertex of the angle. You're not done yet. You'll have a few more words yet. That's the writer's cramp part of today. Okay? There's a lot of words to write down for that because we have to have definitions. We have to have a starting point in geometry. Okay? So we got to know what a point, a line, a plane, a segment, a ray, and an angle are. Okay? Because we use those as the building blocks of geometry. Okay? To describe geometry. So, now, to name an angle. Okay? We can use a number to name an angle. Number 1, angle 2. What's another name for angle 1 using letters up there? What's another name for angle 1 using letters, Donovan?
Angle ABX?
Nope.
Or just X?
Nope. Neither. You use 3 letters, but you got to use them in the right order. The right order. Order is important. So angle 1 is AXB in that order. Angle 1 is angle AXB. Or there's another name to it. What could another name be for it? BXA, exactly. Angle BXA. Those are the 2 names for angle 1. What's the name for angle 2, Jenny? Angle BXC. BXC. And what's another name besides BXC, Shanna? Angle CXB. Okay? Now, I could call this angle just angle Q. Why? Why can I call that angle Q, but I can't call one of these angles X? Because there's more than one angle there. There's not 2 angles, there's 3 angles there. There's 3 angles over there. There's AXB, BXC, and AXC. There's 3 angles. So if you call it angle X, who knows which angle you're talking about? Here, angle Q, you can call it angle Q because there's only one angle there. But here, there's 3 angles, so you just can't call it angle X. That's why we have to use 3 letters. So be careful when you're naming angles that the vertex is always the middle letter, okay? And you use 3 letters if there's more than one angle at a point. Okay, the ruler postulate says we can assign coordinates to letters on a number line. So we can assign numbers to them so we can find distances. And the distance of a line is the absolute value of their numbers that are associated with it if we subtract. So we subtract and take the absolute value because distance is always positive. So when I talked about a postulate there, it's something in geometry that's assumed to be true. A postulate is a statement that's assumed to be true. Now, there are 15 postulates in geometry. Why? Because back in like 400 BC, this guy by the name of Euclid wrote a book called The Elements and named off 15 postulates. And geometry hasn't changed since 410 BC. It's just the tools we use with geometry has changed a little bit. But the book that he wrote is still basically the same as our book today. Okay? We haven't changed much. We just changed the tools and how we learn a little bit. But the basics of geometry have not changed in thousands of years. Okay, so the ruler postulate says I can find the distance between K and L. K and L, 16 and 12. How far is that, Evie? 4. What is KL? It is 4. The distance from K to L is 4. Okay, the segment addition postulate. Let me jump in here quick. The segment addition postulate says that if I have a segment and I have another point in my segment somewhere, that the one small segment plus the other small segment add up to be the big segment. So 5 and 5 make 10. Or if I move B a little bit, 7 and 3 make 10. Or if I may move C a little bit, 7.7 plus 3.3 equals 11, and so on. Okay? As long as they line up in the same line, you can take one small segment plus another small segment and add them up to equal the big segment. Segment addition postulate. Fairly straightforward. Okay? So here we go. We'll talk about collinear points because collinear points are on the same line. Okay, so F, G, and H are all on the same line, so they're collinear. And if they're collinear, we can use the segment addition postulate. So collinear points lie on the same line, points on the same line. Okay, now we're told that GH is 16. And I want to figure out what FH is. To figure out what FH is, I got to figure out what is, what X is. Now it says GH is 16. What is GH in the picture? 2x plus 2. So 2x plus 2 equals 16. And oh, welcome back to algebra. Here we go. How do we solve an algebra equation? What do we do to both sides? First step, subtract the 2. Whatever we're adding here, we subtract it. So we subtract 2 from each side. 2x equals 14. And then what do? Divide by 2. X equals 7. So we're going to stick the 7 in here and we get 16. Stick the 7 in here. 3 times 7 is 21 minus 1 is 20. It looks like FG is shorter than GH. But in fact, FG is actually longer. Don't you always use a picture to think, well, that doesn't make sense. Okay? You got to use what they give you. And most of the time, the picture will make sense. Here, the picture doesn't. How long is FH? Well, it is 36 long. Okay? So you're going to be doing some algebra here. Okay? You'll be doing some algebra. So if KM, the whole thing, is 67, how long is LM? Well, we've got to use the segment addition postulate to figure this out. We have to take KL, which is 4x plus 7, and LM, which is 5x minus 12, add them together to make 67. Exactly. All right. So on the left side, before we can start moving things from side to side, we have to combine like terms. I bet Mr. Hodgins said that a few times last year, right? Combine like terms. What's 4x plus 5x? 9x. What's 7 plus negative 12? Negative 5 equals 67. So then we'll add 5 to each side. So 9x equals 72 divided by 9. X equals 8. Divided by, yeah, I was already thinking of what the answer was. There we go. Thank you, Donovan, for clearing me up. X equals 8. So then to figure out 8 is not the answer. We got to figure out what LM is. So we still have to stick the 8 up there. 5 times 8 is what? What's 5 times 8? 40. 40 minus 12 is 28. That's how long LM is. Okay? So you're going to be doing some algebra today with segments. Protractor postulate. Does everybody know how to use a protractor? Hopefully you do. Hopefully you had your hands on one in middle school. All right. To figure out angle ABC. Okay, to figure out angle ABC. A hits the 0 on the outer scale of numbers. So we use the outer scale to figure out what ABC is. So if we start at 0 and go to 60, how big is angle ABC? ABC is 60 because we start at 0 and we go to 60. How big is angle DBC? That's at 60 as well on the outer ring. But if you go over here, D has 0 on the inner ring, right? So you have to use the inner ring of numbers. And what's the number that matches up? 120. So angle DBC is 120. On this one, they ask, what is BC? Neither one of them is on 0. So we got to figure out what their angles are. So B, if we go here, B is about 47 degrees on the protractor. C, if we're going on the same one, because we need to go on the same one, C is 105. You can't switch which number set you're using. You got to stay with the same one if they're not, one of them doesn't start at 0. So if B is at 47 and C is at 105, how do we figure out how big this angle is? It's the same as finding distance. What do? Subtract their absolute values. So take the absolute value of their difference, I should say. There we go. So take 105 minus 47. That's like 58. And the absolute value of 58 is 58. We're not going to do the angle addition postulate. We're going to skip over that one for now. We're not going to worry about that one. Okay. If SPR is 60, and this whole big thing, SPQ, is 120, what's left for PQR? Those of you who are whispering, 60. You are correct. It is 60. Because 60 plus 60 makes 120 to subtract. Okay. Marks in geometry. If two line segments have the same mark, they're said to be congruent to each other. What's another word for congruent, do you think? Equal. They're equal. They're the same. Okay? So if there are two tick marks, those are equal to each other. Okay? If there's one arc mark, these two are equal to each other or congruent to each other. If there are two arc marks, then these are congruent. Okay, properties. We'll get more into properties when we do proofs at the end of the chapter. But the reflexive property says the exact same things as on each side of the equal sign, such as 8 equals 8. That's a reflexive property. The symmetric property allows us to flip-flop things on each side of the equal side. So if 4 equals x, then we know that x equals 4. Just flip-flopping things on each side of the equal side. And the transitive property says if x equals 4 plus 8, and we know 4 plus 8 equals 12, then x must equal 12. If the first leads to the second and the second leads to the third, then we know the first must lead to the third. Okay, because they're all equal to each other. That's a transitive property. So we'll work with those properties more. They didn't need to stick them in this section, but they did. Okay. If we know, last one here, if we know XWZ, this whole big thing is 127, what's this angle right here? Well, what else do we know besides this is 32? What else do we know? Looking at the drawing. That this over here is how big? This one over here is 32. Why? Because they each have an arc mark. So if this is 32 and this is 32, what do those two add up to? 32 plus 32 makes 64. If this whole thing is 127, take 127, subtract 64, and you get 63. That's what the middle angle must be. YWV must be 63. The reason we could solve that is because we have this thing called an arc mark. If we have one arc mark and we know what that is, then this must be the same. They are congruent, they are equal. Okay. On Google Classroom, you have an assignment sitting out there that'll take you to Savas Realize. Okay, so it'll take you out to Savas Realize where you fill out the answers. So get started on that. We get out of here in another 20 minutes. Yeah, 9:40, so just less than 20 minutes. So out on Google Classroom, you go to Savas Realize and you do the assignment. I will be here to help you with it.